Hi guys, I am here to do a video today about solving equations. So in class we have previously solved equations using our flowchart and using our inverse operations. So as a quick recap, we were given the expression, the equation I should say, including the answer. We've started with our input number as x. And then we've built our equation, so x plus 7 in this case is x plus 7 times 3 equals the expression 3x plus 7. Now the equals to that would go underneath in our second little box, so 3x plus 7 equals 24. And then I've backtracked using my inverse operations by looking above and changing it to inverse. So 24 divided by 3 this time, instead of times 3, is 8. 8 take away 7 is 1, so x equals 1 in this case. And if we substituted that back in to our equation, we'd have 3 outside of 1 plus 7. So 1 plus 7, 8. 3 times 8, 24. Okay? So that is a perfectly acceptable way to solve expressions, but it is very time consuming and it involves a lot of setting up, going backwards and then going forwards and then going backwards. So what we want you to start doing is solving expressions just by showing you're working down the page, which I'm going to demonstrate to you now. So we are essentially doing the same thing. We are backtracking using inverse operations or the opposite operations. So when you're doing it this way, the idea, same as up here, so the idea is to get the pronumeral by itself equaling something. Okay, to do that we're using inverse operations, and I want you to think about the equal sign as a barrier in the equation. So this is one side of the equation and this is the other, and we're going to go over or from one side to the other of the equal sign using our inverse operations. So I'm going to do some of this in a different color pen just so it's a little clearer for you. So the expression I have here is the same as up here, just so you can compare the working. So I have x plus 7 all times by 3 out the front, equaling 24. So here I've got a times 3 and a plus 7, and the easiest way to solve this equation is to remove or take the times 3 and deal with that first. So it's currently times, so the inverse of times is divide by 3. And by doing that, I've removed the 3 from that side, so that's progress. But whatever I do to one side of my equation, I must do to the other. Okay, so I've got to divide a 3 over here as well. Okay, so at every step, you must rewrite your equation. So now I have just the x plus 7 equaling 24 divided by 3. So 24 divided by 3 is 8. Now the only thing remaining is my plus 7. So it's a plus 7 here, so I'm going to do the inverse, which is take 7. And I've got to do it to both sides. That's really important. Okay? Now I have x by itself equaling 8 minus 7 is 1. Okay? And like I showed you up here, if I substituted that back into my equation, I would get the answer 24. So that's how I know I'm correct. Okay, so I'm just going to write that fourth point down. It's a little bit like when we found equivalent fractions. Whatever I do, you do, to one side must be done to the other. And we call that balancing our equations as well. All right, let's do another example. So this time I haven't got the flowchart set up, and I'm not going to do the flowchart for this. I'm just going to show you that second way. So I have x plus 9 times by 6 equaling 72. So again, I'm going to deal with this number out the front of the brackets first. It's a times 6 now, so I'm going to use the inverse to remove that, and that would be divide by 6. But I must do it on both sides. Okay, now I have x plus 9 equals 72 divided by 6, and that's 12. Now I have my plus 9, the only thing remaining, so I'm going to subtract 9 from both sides, to remove the 9 there. And now I have x equals 12 minus 9 is 3. And the last step is to put it back into my equation to check if I've got it correct. So I would have 3 plus 9 is 12. 6 times 12 equals 72. So I'm correct there. Okay, in my next video I'm going to show you some examples with different styles of equations, but this is a very good starting point.